We are now moving on to Unit 11, Lesson 4. We are still simplifying radicals, and this time we are simplifying radicals with variables. Alright, your objective is there. Let's go ahead and get started. This is just a reminder of the two properties we've learned so far. We talked about the product property, where we can take something and break it apart into the product of two squares. So for example, the square root of 32, we can break apart into the square root of 16 times the square root of 2, which is 4 square root of 2. Okay, or we can combine two square roots and say that the square root of, let's say square root of 2 times the square root of 3 is the same as if we take those together and make them the square root of 6. Alright, and the quotient property again says that if we've got a fraction underneath the sign, that we split it up and make it the square root of 3 over the square root of 4, which is the same as the square root of 3 over 2. So let's just review what we learned so far in this unit. Okay, let's go ahead and apply this now. Instead of just with numbers, we're going to apply it with variables. Okay, so let's move on to the next slide. And these are just quick reminders again of the three things that need to happen for radical to be in simplest form. It means there's no perfect square factors other than 1 underneath this radical symbol. So again, an example like the square root of 32. We know that there's a perfect square factor of 32. Okay, square root or 16 is a perfect square factor. So we can break that apart yet and make it equal to 4 times the square root of 2. Alright, again, no fractions under the square root symbol. We just did one like that, where we cannot have something that looks like this. So we got to break it apart and make it square root of 3 over 2. Again, no radicals appear in the denominator of a fraction, so we can't have something that looks like this. Okay, we have to simplify that yet. Whoops, should not be a square root sign there, because the square root of 4 is 2, and that equals 1. Alright, so again, radicals are in simplest form if none of these three things, okay, if we cannot simplify these anymore. And again, now we're applying to variables, so let's move on. Okay, to simplify radicals with variables, okay, if the variable is a perfect square, which means it has an even exponent, then we're going to find the square root of that. Okay, if not, we're going to break it up into perfect square factors. Okay, so let's look at the square root of n squared. Let's translate this to numbers here, okay? What if we did this, the square root of 4 squared? Okay, because this is set up just like the square root of n squared. Well, let's think about this. 4 squared is 16. So what's the square root of 16? That's just 4. Okay, so the square root of anything squared is just the number, okay, or whatever is being squared. So again, the square root of 4 squared is 4, because 4 squared is 16, and the square root of that is 4. So again, we just took our base here and made it our answer. So with the square root of n squared, we're going to do the same thing. That answer is just n. Okay, that's the square root of n squared. Now here, we got the square root of 4 times n to the 4th. Well, that's the same as the square root of 4 times the square root of n to the 4th. Alright, well, we know the square root of 4 is 2, and the square root of n to the 4th, that means what times itself will give me n to the 4th. Alright, well, let's think about this. We've got n to the 4th, that's n times n times n times n. Okay, and we want to know what times itself is going to give me n to the 4th. Well, if I have 2 n's, or n squared, times another 2 n's, n squared, that's going to give me n to the 4th. Okay, so the square root of n to the 4th is n squared. So basically, to find the square root of a power here, okay, you're going to take the power and divide it by 2. So 2 divided by 2 is 1, so n to the first power. Here, n to the 4th power, 4 divided by 2 is 2, so it's n squared. Okay, now that works fine and dandy when we have an even exponent. Okay, if it doesn't have an even exponent, then we need to break it up into things that do have even exponents. So, square root of 4 times n to the 5th. Okay, that's the square root of 4 times the square root of n to the 5th. Well, again, n to the fifth, I cannot take 5 and divide it by 2 and get to the 2.5 power. That's not possible. So I have to break n to the fifth apart into something that is divisible by 2. Okay, so this is like the square root of 4 times, well, let's say that I have n to the fourth power. I know I can do that one. So I have to think n to the fourth times what will give me n to the fifth? Well, I just need an extra n there. Okay, so n to the fifth is the same as n to the fourth times n, because we would combine these into n to the fifth. So now I've broken it apart. Now I can make this the square root of 4 times the square root of n to the fourth times the square root of n. Well, the square root of 4 is 2. Square root of n to the fourth, that's n to the 4 divided by 2 power, which is 2. And then this one, I can't simplify this anymore. This is to the first power. Okay, I cannot simplify n to the first power, so I'm just going to leave it as the square root of n. So it's 2 times n squared times the square root of n. Alright, let's go on to one more slide of examples. Alright, for the first example here, we've got the square root of 24 times n to the 6th. So again, we're going to break this apart into the number part and the variable part. We're going to find the square root of each of those. Well, the square root of 24, okay, we need to think, is there a perfect square factor that goes into 24? Can I break it apart? We can use the factor tree method if we want, or we can use the break apart method. I like the break apart method because I know that there's a perfect square factor 4 that goes into 24. So this is the same as the square root of 4 times, and I got to think to myself, 4 times what will give me 24? So it's the square root of 4 times the square root of 6. And then we still got the square root of n to the 6th power. Well, now we need to pick apart what can we simplify here. Well, I know I can simplify the square root of 4, that's 2. Square root of 6 isn't going to simplify, but this is, because we have an even exponent. So remember, we're going to take this variable and divide the exponent by 2. So 6 divided by 2 is 3. So I've simplified that part and that part. Now all I have left is the square root of 6, which I can't simplify. So it's 2n to the third power times the square root of 6. Okay, for the next example, okay, we've got two square root products that we got the product of two square roots. So the first thing I'm going to do is combine these into one. So I'm going to make this the square root of this stuff multiplied together. Well, 2 times 9 is 18. And a to the second times a to the fourth is a to the sixth. Alright, and now I'm going to break these apart. So the square root of 18 times the square root of a to the sixth. Square root of 18. So I got to think, what's a perfect square factor that goes into 18? And I know that 9 is a perfect square factor that goes into 18. And since 9 times 2 gives me 18, I'm going to split it apart like this. Times the square root of a to the sixth. Now simplify what we know. I know the square root of 9 is 3. I can't do the square root of 2, that's simplified. Square root of a to the sixth, that's a to the third, because again we divide the exponent by 2. And then I'm just going to throw the square root of 2 on the end there. And again, I'm simplified here because I have no perfect square factors under the radical. Alright, and for the last example now, we've got a quotient rule here. So we got to take this and split it up. We're going to split up and have the square root of 7 on top over the square root of 16c squared on the bottom. Okay, now I'm not all the way simplified because I can't have a radical on the bottom here. So I need to simplify the bottom part. This top part, square root of 7, isn't going to simplify, so I'm going to leave it alone. And break apart the bottom. This is the square root of 16 times the square root of c squared. And again, the top doesn't simplify. And lucky for us, both of our square roots simplify. So the square root of 16 is 4, and the square root of c squared is c. Now when I look at this example, okay, one thing that we're going to need to make sure is that we're all the way simplified. So for example, if I had a 2 up here on top, I could simplify the 2 and the 4. If I had another c up here, I could simplify the c's. Okay, but since there's nothing in common on the top and the bottom, I am done. It's the square root of 7 over 4 times c. There's nothing else I can do with that. And if I check underneath the radical, I've got no perfect square factors. I've got no fractions under my radical sign. Okay, and I've got no radical in the denominator. So I am all simplified. And that's your lesson on simplifying radicals with variables. So good luck on the homework.